our lecture number 7 in the quite short course on open source best practices, where we discuss how you, being a programmer, a software developer, can achieve the biggest results you can achieve in GitHub, in the open source community. We discussed it a number of times that you need that to have in your career. You need to have open source contribution because it will help you to become not only a better developer from a technical perspective, but also a more successful programmer, a more successful employee, or even a more successful employer if you will decide to become a startup founder or maybe just a normal company founder. It's good to know how open source works, because this is, in my opinion, the cutting edge of software development. This is where people practice their most interesting ideas, they practice their most interesting methods of developing. And we already discussed how people in open source projects track bugs, how they exchange modifications to their source code, how they review those modifications, how they accept or reject the changes which are coming from their other programmers and in general people who try to help them, and not always to help, but sometimes to just to participate, not necessarily improve something, but sometimes people are motivated just by the curiosity, by just an interest to be there and to touch the code which you created. Long story short, when your code is in GitHub, there will be a moment of time when you will decide to release it, when you will decide to somehow fix the situation, stabilize it, call it a certain version, and call it something which is not going to change in the future. And then you will want to give this as a product to your customers, to your users, to people who are interested in your code. And this is what we call releasing. When we are looking at the source code which seems to work, and we decide that this is the moment, this is the right moment of time to call it version number 1. And then let everybody know that they can use version number 1. And at the same time, we continue the development. We go to the second version. We, the developers. And they, the users, they use the version number 1. So we kind of diverge, we kind of go in different ways. They stay with what we gave them, and we continue with what we want to achieve. And it may go in a number of directions. For example, you give them the version number 1.1, and then you give them the version 1.2, and then you work on the version 1.3. And there will be 3 different groups of people. The first group is using 1.1 and they're happy with that. The second group is using 1.2 and they're also happy with that. And the first group is not planning to switch to the second group. They don't want to upgrade to the version 1.2. They want to stay with 1.1. And you want to work on the product which is in a more advanced version. And these 3 groups, they are not necessarily will overlap. They are not necessarily will want to switch groups. And it happens in software projects. It happens a lot when we have multiple releases, multiple versions, and multiple groups of users who want to work with different versions. And your job as an open source developer is to orchestrate this process, is to keep in mind how you're going to plan those releases and which versions you will give to which people and when. And let's start with a few quotes, and then we go into a number of recommendations, which as usual I will give you, and you will use them in your everyday work. First one, an interesting quote where they say, and that was quite a long time ago, when actually GitHub didn't even exist. They're saying that just making your code available is not enough. It doesn't help. Just by placing your source code in GitHub and just saying that it's there, it's not enough to call it a product. Because people cannot use your stuff without having, like I said, something stable, something fixed at some particular point of time. Because when you have just a number of files on GitHub, we, your users, don't know when and how those files will be changed. We cannot rely on them. We cannot expect any predictability from that kind of repository. We may be interested to look what's there. We may be interested to study your work, maybe even to give you a star, maybe even to fork your code and make some changes. But if we want to put your product into our system, then we need to have a stable release. We need a stable version. And that's exactly what they're saying in this paper, written 30 years ago, that you gotta make some, you gotta put your product into some sort of a component. And you know, this is not a trivial task. It's not something which is easy to do. Most people fail, especially in the beginning, especially the people who didn't do it before. If you look at the code which you have right now, in any language you write your code, think, how can you put it into production? How can you package it to make it a component, as they say? You see, independent components. So make it a component, make it one file. Let's make a very primitive definition of a release. It has to be one file, which I can just download, and it's the file of the version 1.1. The most primitive way to make this file you can think of would be just packaging the whole set of files into a zip archive and label it properly and say, this is version 1.1, and just give it to everybody. That's okay, that may be acceptable. But then think about people who are going to use that file. They will download this archive, they will unzip it, and then what? They will be puzzled of what is next. And there will be some probably instructions, there will be some documentation, but still, if it's just documentation, if it's just instruction, it will be hard for them, it will be difficult for them to integrate your file into their development environment. Especially if we're talking about programming languages where certain practices already are established. People already know how they integrate. They don't expect just a zip archive. They expect zip archive with something inside which is suitable for their IDE, suitable for their packaging system, suitable for their dependency management system. And if your file is just a collection of files, then it will be hard for them to integrate, and they will be probably not so much interested in using your repository. You have to give them what they expect to get. And in certain programming languages, these expectations already are established. 25 years ago, it was a different situation. We didn't have those expectations. We didn't have those best practices. We didn't have those rules and standards and traditions. But now we do have them. If it's Java world, for example, then we expect you to provide a jar file, a jar archive. I don't want you to give me a zip file. I want you to give me a jar file, and inside this jar file, I have some expectations about the files which are there. So I want binary.class files to stay in there. And if there is something else, then I will be very much surprised, and most probably my IDE will be even more surprised than me. So your file will be just rejected. Of course, if I'm super not lazy and you're super important for me and your product is very valuable and I cannot find an alternative, then yes, I will do some work and trying to integrate your stuff into my environment. But most probably, I will find a replacement for your product, some alternative. So next quote is, they're saying that, again, quite old, well, it's like 20 years old paper, which is talking about release planning. Release planning is what you do when you think of when and how you're going to release your product. The first question is when. So you need to decide, it's going to be every month, it's going to be every week, it's going to be once a year. When you're going to produce new versions. And the second question will be, probably is going to be how. So how are you going to package them? How are you going to deliver those files? Exactly how you do that, with what tools, what instruments. And they say that usually it's done not according to any models or methodologies. People just do it sporadically. They just do it randomly, whenever they feel like it. They feel like now it's time to make a release, so they make a release. And very often they do it manually. So they just go into the repository, they read some documentation of how the JavaScript package has to be packaged, and they package it manually, and they place it on npmjs.org, I believe. And that's it. This is what junior programmers do. And I don't want you to do that. I want you to be more professional by thinking ahead and automating this procedure. We will discuss now how you can do that. But in general, that just understand that this ad hoc approach, which means whatever works, I just do it, whatever is needed to be done now, and that's it. I'm not planning, I'm not enforcing some methodology, I'm not following some set of principles or standards. I just do whatever is necessary now to release and forget about it. You have to plan, and I will give you 7 or so recommendations today of how to do it right. And if you have an open source repository, I suggest you follow all of these recommendations. Let's start with the number 1, which is probably the most important, is that you have to release when it's different, not when it's good. Let me elaborate. Many people believe that we release the software when it's perfect. We keep developing, we keep making changes, and at some point of time, we know that this is the perfect product. That's why we release. This is the main trigger for these people who we disagree with. The main trigger for them is that we do the release when the product is ready for customers, because we don't want to disappoint our customers. That's the reason, that's the logic, that's how they think. Because if you release something which is not perfect, then of course your customers will not be happy. They get the version 1.3.2 and they run it and there are bugs. So of course there could be bugs, but we don't want to know about those bugs when we release. We want to be 100% sure that everything is perfect. That's a wrong thinking. You don't think that way. We must think differently. We must understand that in any software product, there are bugs. And if you're actively developing a software product, you actively register those bugs. You actively maintain your backlog of problems, backlog of issues. And especially in GitHub, where we have those issues registered there, you look at them, you know them, but you keep making releases even though issues are known, even though issues are registered, even though issues are in there. No matter that, no matter what we release, that's my understanding, and I will show you a number of scientific papers and scientific opinions about that. But my personal understanding is that when the product is different than the previous version, this is the time for release. We know that the previous version was working this way, and that was 5 days ago. The version which I have now is a little bit different from the previous one. Well, in a good way. Different, let's say positively different Probably I need to change it here. Positively. In a good way, different. So of course, if the 5 days ago we had a version which worked and we didn't improve it in 5 days, we only broke something, then there's no reason for release. But if we manage to make at least a small improvement, it is different a little bit, that's a reason for release. Then you just click the button and you make a new version. How to label this version? That's a separate question. We're gonna discuss it later. But you make a release. You don't wait until everything is perfect, because it will never be that way if you are a professional developer, because you will have bugs. You will register them, you will find them, you will know about them, you will have a backlog of bugs, and you will keep finding them with every next release. You give the new functionality to your users and you get back the bugs from them. So we release when it's different. Now let's see what people are saying, what people were saying about that question. And that question of when to release, it was puzzling, or it was troubling people for many years. Look, they started thinking about that like about 50 years ago. And there was a model developed at that time, which apparently, I didn't know about that. I just found out just recently that the model is called Goel-Okamoto model, by the last names of the people who suggested this model. And I believe it's popular, or it's known, because it was the first one. They were the first, or maybe among the first, but most probably the first, who suggested how to make the decision when the product must go to production. When is this software release time? When it happens? And they suggested that there should be two criteria: software reliability and total expected cost. So basically, they suggested that we need to look at two metrics. Metrics. I believe there are numbers. So metric number one is reliability. So we are just looking at the product which we have in front of us, and we test it somehow, and we see that there are certain amount of problems there. Let's call it one metric, reliability, which is difficult to call one metric, but they don't suggest a specific metric, they just say in general. So look at the quality of your product, but not in a binary way. Not like it works or it doesn't work, but look at it as a metric, reliability. And of course, the more you test, the more you develop, the better will be reliability. Well, provided you know what you're doing. So you increase the reliability. At the same time, the cost of this process also increases. The longer you develop, the more expensive it becomes. Of course, it becomes more reliable, it becomes more stable, you fix more and more bugs, because you test and you fix, you test and you fix. At some point of time, you have to stop. So that's going to be your decision, which they suggest to make. You measure the amount of effort you need to spend more and more, and you measure reliability. At some point, you make a management decision. You say, enough, it is reliable enough. It's not 100% reliable. But that's reliable enough for us to go to production, because we're basically running out of money in a primitive way. We don't necessarily run out of money, but we kind of spent enough on this cycle. Two factors. They just join at some point, at some particular point on the graph. And I'll show you a few graphs a bit later, how they join there, and then what happens. What happens? We know what happens. We just go to production. This model was improved, extended, but it seems that people actually liked that model a long time ago. And what happens after that actually is just an extension of this model from different points of view. Different people say different things of how you make this decision, but in general, the decision must be made basically based on these two criteria. And this paper, which was published about not like 6 years after the original paper, they are saying that we must they extend the model. So they take this model, which we just discussed, and extend it by evaluating both criteria simultaneously. So basically, if the previous paper suggested that we need to compare those two criteria, but these guys, they're saying just look at them at the same time and in dynamic, in progress, decide when to stop, which is exactly what I just told you. But they claim that they are suggesting that this is the way to go. And that's the graph from them, from their paper. And look at what happens, look at how they suggested to visualize this process. So look, this is the testing time, goes this way. This is testing time, goes from the left to the right. So at some point of time, we need to make a decision. And here are two graphs. This one, total software cost. How much we invest into testers, programmers, and so on. So that's the line. For some reason, it goes down first, and then it goes up. And then here we have software reliability. So we improve the quality, basically, quality or reliability. So at the beginning, it's like 0, very unreliable software. And then we increase, and at some point of time, we kind of plateau. So that's what they say. So you kind of stop making any productive changes because you fixed the majority of the bugs which were critical, which were visible, and now you can only fix some cosmetic bugs, well, to some extent. So they suggest to release maybe like here or maybe here. That's up to the people with the money. It's up to the people who decide what's more important, the reliability, which is here way higher, or the cost, which is also higher at that point. So maybe we can release here where reliability is way lower, but the cost is also lower. So, well, on their graph, the difference here is not so big, right? So here's the software cost is small, but the difference in reliability is huge. Definitely in reality, these graphs, they may look way different. And this balance may be also not as positive as these graphs demonstrate. But overall, you got the idea. I'm showing you this in order to convince you that you don't wait until your product gets perfect. Because 50 years ago, people understood that it's never happened. It most probably will never happen, and it's unreasonable to wait for that moment of time. It's way more reasonable to just understand that I cannot test anymore, I cannot fix bugs anymore, and I want to release because my customers are waiting. And in a moment, we will discuss why it's good to make multiple releases. But before that, let me show you a few more quotes about this decision making. That's the author who we all know and love for the books he wrote for us. Steve McConnell saying that, basically confirming what I just told you, that the question is whether to release software. It's a difficult question, to release or not to release. That's what he's saying. And the answer must be between the poor quality and high quality late. So poor quality early or high quality late, which of course the question of money as well. Is the software good enough to release now, and when will the software be good enough to release? So it is critical even to companies' survival. It is also critical to the survival of your open source project as well. In my opinion, the sooner you release, the better in open source world. The bugs, people will forgive you if you quickly fix them. If your release cycle is fast, like I release today and they report me the bugs tomorrow morning and I fix them tomorrow morning, and tomorrow by the end of the day, I release the new version. This is way better than I wait for 2 days and then I release a perfect product, which I believe is perfect, and I release it tomorrow. For open source world, the speed, in my opinion, is more important than quality. The quality will be forgiven if you quickly fix and release. People can understand that they can rely on you. They see that you're actively moving forward. You're actively making new versions. And that's perfect. It's way better than you sitting there and developing for a long time, and they're all waiting and they don't know when it's going to come out. And when it comes out, nobody's going to trust you that you have no bugs. Because we're an open source. We know that all products, they have bugs. So it's better to not do it this way. Make releases. Don't be afraid to make releases, and make it when something is changed. Like I said, when it's different. And also some statistics. Look, they found, and that's quite fresh, it's just 2 years ago. They found that open source packages are typically fast in releasing. Well, they're talking about security fixes, but in general, I believe open source is fast in general. If we're talking about real open source products which are popular, which have 1,000 stars, for example, they release just like that, next day, because people are very motivated to release them. People love them, so they do it fast. And this is 4 days, look, average. And this is the time for the release. So it's a new version. The version number 1, then the version number 2 comes out in 4 days. Of course, for the security fix. But for other fixes, the time is not much longer. Well, it shouldn't be. You can do a similar study on a different kinds of releases, but I believe that popular open source projects, they release quite frequently. However, they say 25% of releases still have a delay of at least 20 days. Well, 20 days is longer, definitely, but still it's much faster than not open source projects. Because if you work in proprietary projects, you can confirm, you most probably agree with me that those releases are taking way longer. And the companies, they release internal products for 3 months, 6 months. I've seen situations where people are waiting for half a year before the product is ready. And they don't want to release earlier because there are no actual users in a close contact with them. Because there are marketing departments, there are business levels, and the customers are far away. But in open source, the customer is in front of you. The customer either gives you a star, downloads your product, and reports back some bugs, or even comes back with pull requests, which is extremely active and extremely motivating customer. Let's continue. So, recommendation number 2. Fully automate the release process, avoiding any manual intervention. That's a mandatory recommendation for the automation. Many people still believe that this is not important, or it is too expensive, it's too difficult. But you must organize your process. You must configure the way that you release automatically. So you don't need to do anything manually tomorrow in the second release, which you did for the first release. You should not repeat any operations manually if you did them at least once. And one of the very famous and good books about automation of release process and in general of software engineering is this one, which I highly recommend you to read. It's called Release It, and it's quite old already. And look at what the author is saying. Releases should be, sorry, probably B I lost here, should be about as big an event as getting a haircut. That's an added benefit of frequent releases. It forces you to get really good at doing releases and deployments. You need to make releases frequently, and it has to be a routine procedure for you. It shouldn't be a surprise. It shouldn't be a special operation. It shouldn't be something which every time takes a lot of brain power and a lot of stress. It should be something routine, very routine. In order to make it super routine, you write a script which does everything for you, which takes all the necessary files, puts them into the right archive, gives the right name for the archive, sends this file to the place where it has to be sent, notifies, writes the release notes, notifies all the necessary people, everything with one script or maybe a number of scripts. But the whole point is that you don't do any steps sitting in front of the computer. You should just click a button, which is also recommended by another very popular and very useful book, which you also must read. It's called Continuous Delivery, and it's also already quite mature. So the authors are saying that that in order to make a release for you in your project, you have to do two things every time you do a release. The first thing, you decide what is the right version for this release. Previously, you released version 1.5. So what is going to be today? 2.0 or 1.6 or maybe 1.5.1? These are basically three types of versions where you can go from 1.5, I believe. So if you had 1.5, then you have three options to go. 1.6, it's going to be 2.0, it's going to be 1.6, or it's going to be 1.5.1. We will discuss it a bit later. What does it mean? Why only these three options are in front of us? But that's the decision you have to make. And this is what they're talking about. To pick the version. That's your job. And then your next task to do is to press the deploy button. So you have to organize everything the way that nothing else happens aside from you clicking the button. That's how simple it should be. And ideally, it should be possible for anybody to click that button. It shouldn't be only for you, because there could be other people working with the project. Could be other architects, could be other maintainers of the repository. So should be some sort of permissions, some sort of rules which they follow. If they want to release, they just know who can do that, who has the rights, who has the permissions. These people just click the right button, and that's it. And the product goes to production. Think about your projects right now. Do you have that? Can you be proud of such an automation in your repository? Can you just click one button and it goes out? Well, it's not technically a button, of course, because here they say deploy button. It's a metaphor, of course. We don't have the deploy button. I don't have deploy buttons in my project, in my repositories. I don't click the button. I use this system. You can find it on GitHub, Rulter, or just go to rulter.com. So I use these robots, which helps me to do the releases. So I don't click the button. I just say I go to a GitHub issue where the release is prepared, and then I post a comment. I say Rulter deploy, for example, deploy, or sometimes I do release, and then I say version or tag equals to 0.1.3. So I just give an instruction to the robot, but that's all I'm doing. I'm just posting a message. It takes me 5 seconds. I choose the version and I post the message, and everything else happens automatically. So basically, in order to make it happen automatically, I spend some time earlier. I spend some time to write a script, which does everything automatically. And I actually invest some time into this script every now and then. When something goes wrong, the script doesn't work, so I just fix it a little bit, I improve it, it happens. And it happens a lot. But I never do it manually, that's the point. So if the script stops working, I don't do this job instead of the script. I don't replace the robot with myself. I just fix the robot. Because I remember that tomorrow, I don't want to do it again manually. I'm too lazy for that. I just want the robot to always do the release job for me. And GitHub Actions is probably one of the best candidates for such a robot. Because usually people automate the release process like this. They just configure GitHub Action to react to Git tags. So you just create a new Git tag. You push it to the repository. GitHub Action picks it up and creates the release. Well, starts the container, runs the script, and makes the release and publishes the release where it belongs. That's how usually people automate this process. We are not going to discuss the details of how to do that. That's quite technical. You can learn it on internet. It's not a rocket science, and it's something which changes every day. So today people automate it this way. Next year they will do it way different. Just look around and see what are the best practices for this automation. But the main lesson I'm trying you to learn is to make sure you don't do it manually. You never publish a single package to npm.js manually. You don't do that. You don't do it from a command line on your laptop. That's wrong. As they recommend, if you go to their documentation, to the npm documentation, you will see that they recommend when it's ready to publish to the storage, to the place where all the packages are published, you just run npm and you say publish there. But that's not how you do it. You don't do that on the command line, but many people do. Many people read the documentation and they think, oh, that's right, I'm going to do it from my laptop. I just say npm publish. Don't do it. Teach the robot to do that. The robot will do npm publish, but not you. And now to the topic which we touched already a little bit. You release frequently. So you release not only when something is changed, but you try to do it as frequently as possible. Because you can wait, actually, until you get more changes. But this is not the best strategy. And look at what people were saying some time ago. I found this paper by accident, but look what I found, actually. This is 1996. This is something which we must respectfully disagree. And maybe they said it because it was a long time ago, because situation is changed and now we understand the situation differently. But look at the quote from them. They're saying, then it's wise to try to avoid scheduling small error correction releases. So they're suggesting to avoid small releases, and they say instead, the manager should try when possible to package small error corrections in the release with larger enhancements. So if you have a version 1.5, and then I'm coming to you as a user and I'm saying something is wrong with your version, please fix it. And you just fix one line there. And now the situation is a little bit better. So they are saying, no, don't release 1.5.1. Wait until you have 1.6. Wait until you have a larger block of changes, a larger piece of code, and then you release. This is probably motivated by fear of instability. They're just suggesting this to managers who are not strong enough to handle the situation of bug reporting. This is good for people who are afraid of bugs. We discussed that on probably the second lecture about bugs, that we must be bugs welcome. We must enjoy seeing bug reports. We must enjoy listening to the feedback, the negative feedback from our customers, because this is how we make the product better. We, instead of waiting in fear, until the product is super stable according to our understanding, and then package the whole thing together and giving to the customers. Instead, we must openly and actively and fearlessly deliver smaller changes, frequent smaller changes. So we disagree with that respectfully, and I only can forgive them because it was a long time ago. So actually, if we move forward in time, then we will see the quote coming from the paper which is younger, and they're saying quite the opposite. They're saying that we found that shorter release cycles, with shorter release cycles, users do not experience significantly more post-release bugs. Bugs are fixed faster, and users experience these bugs earlier during software execution. So it means exactly what I just told you. More frequently you deliver to the customers, the faster they will reply to you, the faster you fix, and in the end, it's going to be, you will not experience significantly more post-release bugs. But I believe that you will experience less post-release bugs. I think that the faster the cycle runs, the faster you release, the better for everybody. And remember the quote about the haircut. You will automate your process so much that it's going to be very fast, very stable, very secure, very reliable. I'm talking about the release process. So everything will be packaged correctly, all the files will be checked, the package will be tested, and deployment will be smoothless. So everything will be how to say, the whole machine which does the release will be running and working non-stop. Because if you delay for too long, if you don't release, let's say, for 2 months or 3 months, and it's open source, then when you try to release it in 3 months, the chances of failure are very high. Because for 3 months, a lot of things could change. A lot of things probably have different principles of work, have different pipelines, they have different, maybe the passwords also changed, many things. And you must test your release mechanism, your release pipeline, as soon as you can, as frequently as you can. Don't be afraid of creating hundreds of releases on GitHub, maybe even thousands. I've seen a project, I didn't show you it here, but I remember I even tweeted about that. A project where they have like 25,000 releases or something. So they release literally like 10 times a day, maybe even more, not 10, maybe 100 times a day. Don't care too much about the platforms where you put your code. It's cheap. This storage is not so important right now. These bytes of code which you consume there, it's nothing. And most of them, for the open source, they're free. They're sponsored by large organizations like NPM.js, for example. NPM.js, this is the storage for JavaScript packages. It's GitHub now. It's owned by GitHub, which means Microsoft. So this platform is basically hosted on Microsoft servers. So it means it doesn't cost anything to you. So release it every day. You release it every hour. You make some changes, you improve a little bit, you see that your product works a little bit better, click that deploy button, create a new tag, let it go to NPM.js. Don't wait for too much. Okay? Next one. Semantic versioning. Probably you know about that, but if you don't, I will tell you, I have to. Because this is the way how we name packages these days. Well, I think it was introduced maybe 10 years or even long, like I don't know exactly when, but that was introduced a long time ago, this mechanism of versioning. Before people introduced that, all the different packages, they were different principles of giving names and versions to them. Look at the packages for Linux, for Ubuntu, for Linux operating system. I don't think they use that stuff now. All the names are super ununderstandable. When you install in Linux, when you install something, you will see different packages coming in. Look at their versions. They're all crazy. The names are crazily. The names are completely chaotic. So people give version names. I'm talking about the names of the versions. So they can name, for example, my version is 1.0 _ alpha 0.2 B Ubuntu, for example, and .zip, something like that. So who knows what it means? Nobody knows. Or they can give you a version 1A, 2, and then something beta, and then underscore, I don't know, hello, and then 0.5, 0.3. I've seen different versions like this. So people at some point of time decided to not do that anymore and to use semantic versioning. Semantic versioning looks like this. It's actually a website, so you can go to the website, which is called semver.org. And there they provide the rules. So they say that any software product must have 3 numbers in their version. Number 1 is the major part of the version. Number 2 is the minor part. And number 3 is the patch number. The major version stays there for the changes which are breaking the interface. So for example, if you have a JavaScript library, and in your library there is an object which is called foo, and in this object I have a method hello, and then you decide to introduce a new version, and in this new version there will be method object foo, and will be a method bar, and you delete the hello method. If this happens, it means that this is a major change, because I cannot use the new version if my code expects the method hello to be there. So you are breaking my code, and because of that, when you release the product, you increase the major version. For example, this was the product of the version 3.7. And this, when you release, you have to go to 4.0. So you increase the major version. From 3, you jump to 4, because you break the interface. The minor version, you increase it when you introduce new functionality. I believe this is what they're saying here. Yes, when you add functionality. It means that if here you have full hello, but you don't delete it, this hello, you keep it there, the hello stays, but you introduce the method bar. In this case, from version 3.7, you go to version 3.8. Make sense? It's a minor change. You don't break anything. You just introduce new functionality. And until you introduce more and more and more, you just increase the minor version. That's how you can move from version 0.1 to version 0.386. Because you made so many new features there, but you never deleted anything that was here. So the user who was using your version 0.1 10 years ago, they can easily take your version 3.86 and everything will work for them. That is called backward compatibility. So this version is compatible with 0.1. But if you release 1.0, then it's a message to me, your customer, then this one is not backward compatible to 0.386. And finally, the number which goes at the third place, which is the name of the patch. You give this version when you fix existing functionality. You don't add anything, so you had this foo.hello, and you make a fix to this method. So nothing is added, nothing is deleted, just function hello didn't work before. And now you fix it, and it starts working better. Then you release from 3.7, you release 3.7.1. If you make another fix, you go for 3.7.2. Every time you fix, but not add anything new, you just increase the third so-called patch version. That's it. That's the idea of semantic versioning. If everybody will follow that, if everybody will listen to this simple principle, then the world of software development will be better, because everybody will understand each other. I will just look at the number of your product, and I will know what is good for me, what is not, which version is suitable, which version is not. I suggest you to follow this semantic versioning paradigm. Next one. Every time you release your package in open source, you must generate so-called release notes, called RN. Release notes. This is basically a piece of text, which is a message to me, your user, telling me what's inside. You released versions 1.3.7. Before it was 1.2, for example. And you give me 1.3, let's put it this way. So my question is, what's inside? What did you do? Why you increased the version? Is it important for me? Should I upgrade from here to here? I need to know. I'm not interested to study your code, right? I'm not gonna investigate every line of code you change there. I just need to know the summary of what you did. And you can generate those release notes in GitHub automatically. Every time in GitHub you create, if you manually create the release, which I suggest you don't do, then you will be able to choose the version of the release, and then you click this button, Generate Release Notes. I did it on this screenshot. I did it for our project, for our programming language which we developed, and it actually generated me just yesterday, generated me this text. So this text is automatically generated by GitHub. There is nothing interesting there. They just summarized one by one all the pull requests which we merged into the code base since the previous version. It may be okay for some products, just a simple summary of changes made there. But imagine a user who will have to read all of that and find out there whether the changes are important, whether something critical is there, or maybe it's all just cosmetic changes. For a large release, if you make a release of which contains a few dozens of changes, such kind of release notes will look not user-friendly. That's one problem. And second problem, generating release notes, in this case, it should be done manually. I'm not sure whether the API of GitHub allows you to click this button from the robot. Maybe they allow. I'm not sure exactly here whether it's not yes or not. But remember that we don't want to create releases manually. We don't want to go to this page ever. If you have to go to this page, if you have to click all these buttons manually, that's, in my opinion, not a good idea. Because this all has to be automated, and you have to just push the tag to the repository or call the robot, and the robot will do everything for you. So the problem remains how to generate those release notes for your product and make them look attractive, make them look understandable for your end users, for the people who will take your product. And people do read those release notes. They care. Especially when your product becomes more and more popular, then this information becomes more and more important for the users. Because they use your previous version, they rely on your previous version for a number of months or maybe years. And then a new version comes out, especially if it's not a bug fix, but it's something like a minor version or maybe a major version. For a major version, it's a mission critical to read the notes and understand how exactly you break the functionality. Maybe you deleted something which is not important for me, or maybe you deleted something which is very important for me. I need to make a decision whether to upgrade or not. There are a number of systems right now which use AI, which use, I believe, large language models to generate release notes for you. And just a simple Google search gave me, how many? 8 suggestions, 8 platforms, which can help you with that. Automatically, manually, all the different ways. You just tell them how much your code changed, and they generate you a summary for your customers, explaining exactly what happened there. That's pretty effective. But I don't have experience of using them. I don't know how they work. I never tried. But I understand that this may be the future of releases. So most probably GitHub will use one of them, or they will design their own system for release notes generating. Because this text looks really not interesting. So in this case, it's not important even to generate this list, because we can get this list from Git history. I can just go to Git history and I can select the dates from this time to that time, and I will see exactly that. What's the point of writing there something? It should be something more meaningful. It should be something which tells people why the changes have been made. What was the intent of the developers? What is the trajectory into the future? What will happen next? How many more changes we may expect? AI can at least guess about that. That kind of automation which GitHub provides now is not effective, in my opinion. But I don't use that either. I don't use AI and I don't use release notes generator, because I use the robot, which for me generates a very simple list of changes, which is similar to what you just saw. It's also not good, but I'm using my own robot for all my projects. I'm thinking now how to integrate AI into my robot so that it becomes so that it starts generating release notes. Maybe I will use one of these systems. If you're interested, you can contribute, actually. You can find the project on GitHub. It's called, again, Rulter. And maybe you can help me with creating this connection with some AI system, maybe ChatGPT as well, and then collect the information about what was changed between the releases, after the recent release up to the current moment of time, and package this information somehow into a prompt, send it to a large language model, and then see what is suggested from there. Maybe it will be better than what we generate now. Okay? Let's see what researchers are saying about release notes. It's quite fresh paper. They are saying that they studied how these release notes are being generated, and they found out a few interesting facts. First, they're saying that producers, these people who create release notes, they are more likely to miss information than to include incorrect information. So people just forget what happened there. and they just write what they remember, but not everything, especially for breaking changes. They broke something, they deleted something which is important, and they forgot about it. And they release. Second, improper layout and may confuse users. Layout of the release notes. There has to be some structure. Maybe a list, maybe a table, maybe the proper highlighting of the proper words and the proper sentences. People don't do that. Or they do it improperly, incorrectly. And users get confused. They read your release notes and they don't understand exactly what did you do. So pay attention. When you write release notes, think about people who are going to read them, and they will. And the more of a high quality your release notes are, the more people trust your GitHub repository. They will see that you are doing it carefully. And that means we can use your product, we can trust your product, we can rely on your product. The more discipline you put there, the more attractive release notes look, the better for you. The more customers, more contributors, more pull requests in the future. Everything more. Number 3, many users find release notes inaccessible due to link deterioration, lack of notification, and obfuscate RN locations. So basically, people don't know where are the release notes. So how I can understand what's in the version 1.5.1? Exactly why it was released. I don't know where to find this information. That's the problem for users. So when you write the release notes, when you finish the release, when the version is there, then go to maybe README file and mention it there somehow. So make a connection, make a link between your README file and your release notes. Somehow like that. Because people find it inaccessible. I don't know where they are. Let's put it in simple words. They don't know where to look for them. And number 4, automating and regulating release notes production remains challenging despite the great needs. That's exactly what I told you before. We need proper release notes generating mechanisms. We need to generate them in a right way, using AI or not AI somehow. But we don't have that. So in the industry, we don't have proper tools right now. If you can develop, well, I showed you that there are many tools already on the market, but maybe you can also contribute. And eventually, maybe in 2, 3, 4 years, we will have something better than we have now. But for now, we are in trouble. That's what science is saying. They got all of that by talking to people. So they just asked a number of developers, they asked them the question about release notes, how they find them, how they use them, how they write them, do they have problems and challenges in writing them, and the answers which they provided, they just analyzed and just summarized for us. That's all. And final recommendation, we must publish binaries. People don't do that. And I'm talking about packages which you built and now which can be used by other programmers. I call them binaries. Not necessarily all the time they're going to be binaries. Very often they will be even text file, but packaged in archives. For example, again, npm.js, they will publish your, I think it's going to be zip archive, which is named, for example, it's your some library ABC, and it's 1.0.zip. So that is your binary file. Of course, if you look inside, you will see just text files. You will see JS files here. You will see some text files here. You will see maybe some CSS file maybe there, maybe HTML, something like that. That's going to be the content of this archive. But when it's archived, it's a binary. It's a binary which you are supposed to distribute, to give to people. In order to give to people, you have to place it in one of the places where we people know how to find your stuff. And there are a number of such places, well known for every programming language, for every programming technology, and you must use them. Oh, that's a typo. It's npm.js. You see, I made a mistake. They didn't exist 15 years ago. Well, they existed, but there were many of them. Eventually, with time, people kind of agree that it's okay to have one single place for JavaScript binaries. It's okay to have one single place for Java and Clojure and Kotlin and Scala and all the Java bytecode based programming languages. It's called Maven Central. And it's okay to have one place for all the Ruby gems. It's one place. You can create your own place. You can create your own platform where you will allow people to host their binaries. But nobody gonna use them. Nobody gonna use your platform, and nobody will like to download these packages from your platform because people agreed that it's okay for all of us to have just one single place, well, for every programming language. I think it would be even better to have one place for everything. But we don't have it now. We have kind of isolated locations for every programming language. But you must use that. When you do the open source, when you develop open source products, it's not enough, as we started this lecture, it's not enough just to have your files. And it's not enough even to just release your files on GitHub, which people do quite often. They just package everything and they keep the release on GitHub, and they believe that this is the way to go. This is the way to distribute their software. And sometimes they do in the README file, they just say, if you want to use our product, first step, you do git clone. So you clone our repository, then you install it somehow locally, or you package it somehow locally, and you get the product. This is just immature. This is something you don't do. You must let me take your package from one of these publishing platforms. And one of the reasons, well, at least for me, it's number one reason why I prefer these platforms instead of your GitHub repository. Because I know that from these platforms, the artifacts are not removable. Well, unfortunately, it's not true for all the platforms. For example, you can go to npm.js and delete your artifacts from there, which is, in my opinion, completely wrong, because for Maven Central, for example, you cannot delete anything from there. If you publish to Maven Central, it stays there forever. Even if you are the author and you decide to delete it for any reasons you may have in mind, it's not possible. I think this is right. So this platform is immutable. You can only put there. But NPM, I think Python you can also delete. In Ruby gems, I believe you can delete. So unfortunately, the design of these platforms are not perfect, but still, it's still better than a GitHub repository. But I'm coming from the Java world, so maybe that's why I kind of used to have immutability on Maven Central. And that's why when I see when I see a software package staying on GitHub and not being released to Maven Central, I simply cannot rely on that. I cannot use it as a dependency in my project because I know that the author of this GitHub repository can just delete the whole content. And in a few years, I will not be able to continue using it. But in Maven Central, I don't care about the author anymore. You do whatever you want, but you release the product. You already have the fixed version there. I'm completely detached from the author, from this moment of time. And that's important for open source, because we know in open source people are doing whatever they can do. People sometimes delete repositories, people sometimes damage their own repositories, people, as you may know, do some protestware, so-called, so they intentionally corrupt their own code in order to hurt somebody. It happens, and it happened recently. You know stories about that. And in order for me to protect myself against all of that, I want to rely on the platforms which are more trustable. To some extent, of course, these platforms may also corrupt the code. They may also prohibit me from using this code in the future. It may happen, but it's more trustable than individual repositories. So when you have a small project, even if you have very small open source project, even if just a few files, if it just does very, very small thing, still practice yourself and release it to, let's say, Maven Central. You will see that it's not so easy. You will see that these platforms, they will require you to do certain things inside your repository, inside your packages. They will demand certain files to be visible there. They will demand certain formats of these files. They will demand certain way of giving versions to your products. They will ask that you supply the documentation together with your Java code and the class files. That's what Maven Central is doing, for example. There will be demands, enforced and forced, enforced, forced. There will be demands forced on you. You will have to obey, and that's good. It's good for the community, for the ecosystem, but it's hard for you. So you will have to go through all of that. You will have to learn the rules, and I suggest you do that. You do that for a small project, then you will understand how to do it to a bigger project. And every time you create an open source project, the first step you do, you automate the release process and you release the first version. I usually, when I start, I release version 001. This is the first version which goes out. When I make the product, nothing is ready, the functionality is not working, I just have a few files, just a very high-level skeleton. I immediately introduce the build pipeline, release pipeline, and I click the button, and the first version, 001, goes to Maven Central or NPM, and whatever it goes. And then I continue the development. Then I introduce some functionality, then I click the button, 002 goes there again. And then it goes to 3, then it goes to 4, 5, and eventually when it becomes stable, when I think that, okay, this product I'm more or less proud to show to the community, then I do it like this. From this moment of time to that moment of time, it could be, let's say, 1 month. And during this 1 month, I may create like 20 different releases, 20 different versions of my product. I suggest you follow the same procedure. So that's it for now. That's all I wanted to tell you about how to organize releases in your open source projects. Automation is the key. Focus on that, and your repositories will be more attractive to customers, more attractive to contributors, to people who will join you. If you don't have release automation, your repository is immature. Your repository is not so interesting, not so attractive to people who will try to contribute. That's it. Thank you very much. See you next lecture. We have the lecture number 8, the last one, next one, and that's it for this course. Bye-bye. Thanks for your time.